Okay, so right now we're gonna go through our code for lab 3. We're gonna start with the ALU module because that's kind of the heart of the project. And the third thing to note is that our ALU was improved compared to the previous lab 2, because we were able to fix some mistakes that were made. For example, our subtraction model was not perfect, but in this case right now it's working properly. And we also added a mode to get a sign out when the subtraction is negative. So as we can see here, subtraction, it's gonna be 1011 subtraction simulation, and we can see that right now there's a new output sign, and one's gonna be for negative. For example, we're gonna go here and we can see 6 minus 9 is going to be 3 as magnitude, and then a 1 minus 1 for sign. That's for the OP3, and then if we go to OP5, the case should be the same. So this project we decided to replace not B because we consider it was not such an important function, and part of the project of developing lab 3 was to implement something new. In this case, we decided to implement a magnitude comparator. So basically it would evaluate if A is greater than B, or A equal than B, or A lower than B. And then we made a wire to assign that greater it's going to be 1, lower it's going to be 2, equal is going to be 3. And we can see here the if case, and so if the user wants to check the magnitude comparison between A and B, depending on the output 1, 2, or 3, he or she would be able to know if it's greater than, lower than, or equal. And so basically that's it for the ALU, and then now we're gonna go through the changes that Daniel implemented.
Okay, so we'll start with the comparator. This is the smallest level, and this is a small comparator that takes bitwise, like only 1 bit of A and B, and gets in a 1 for either greater than, equal to, or less than, and it takes in previous entries as well, so that if the previous entry is greater than or equal to or less than, this automatically becomes the same thing, so that it ripples through. The magnitude comparator, as you can see, is just instantiating the same thing. So we can see here 0 and 0 are equal, so A equal 1, A equal B is 1, 2 and 4 is bigger, so A is less than B, 4 and 2, and so on. Built a random number generator, and this random number generator works off of an LFSR. In our case, that LFSR was this. So it's an 8-bit input LFSR. It's of type Galois, means that these are run in parallel rather than in series, which makes it better for hardware. So this is the test bench. It shows right here that there's 3 different instantiations of the LFSR: the clock, the load, and the reset. So the seed is the same, and yet the number changes. So this is basically the output. No certain discernible pattern, but if you...
This is just a little bit of the test bench that we can see in real time right now, and we're planning to do an FPGA test that is not included in the video because of logistics. And so what we wanted to accomplish with this lab was to try different modules, different tools that we wanted to further implement in the project of EC311.
Our biggest failures arose from just the sheer size of the lab 3, and the fact that there was a lack of modulation in part.
So that's it for our video. Thanks for watching, and I hope you enjoyed it.